Now children, we will see some questions based on electron gain enthalpy or electron affinity. So delta, EGH or say call EA. As we have discussed in the last video how the factors are affecting the value of EA, electron affinity, let us see in general in a period, if we move from left to right children, the value of EA or electron gain enthalpy goes on increasing in general. In a group, top to bottom when you move, the value of electron gain enthalpy goes on decreasing because the size goes on increasing, and we have seen it is inversely proportional to size. That much we have seen. Now it will become more clear to us if we see in terms of questions. Children, we are given question like FClBri, which out of these will have the highest electron affinity, highest helium, first question. So what happens children? We know they belong to same group, top to bottom, size is increasing, I have drawn. And you also know, hence the value should go on decreasing. It should be decreasing. I should have the lowest value, F should have the highest value. Normally it is expected as per the factors we know. But we know chemistry is full of exceptions. What happens here children? F has very small size. Electron is easily attracted here. So what happens? Electron gets easily attracted, as well as it is expected that it will be easily added up also. But what happens? Due to extraordinarily small size, with the entry of electron here, there start inter-electronic repulsions. With the result, a lot amount of energy is consumed to overcome those repulsions. Hence, what all value was expected for the energy to be released out, a good amount of that is consumed in overcoming those repulsions. With the result, the value of the energy which is released goes down than the expected value. So what happens? F has value lower than the expected. Next is Cl, which should have had the second highest but now becomes the first highest, because here the size is small but not that small that they start electronic repulsion to that extent. With the result, the value of F gets lowered due to inter-electronic repulsions, and here almost negligible or say no repulsions at all. And here a good amount of energy is consumed in attracting those. So what net value was expected has to be much lower. So F, which was expected to have the highest value, comes number 2, Cl comes on top. So I repeat for the last time, F gets lower value due to inter-electronic repulsions, which in turn are due to its extraordinarily small size. So Cl, F, Br and then I. So this is the trend. So Cl has the highest value. In general, in a period, halogens have the highest electron affinity value in general. In negative. Then question number 2, which will have more negative value of electron affinity or say delta EGH? N and O, they belong to same period, and N and O we are moving this side. So naturally the value should be increasing, and it increases also in general, but we know case of N, half filled, very stable configuration, difficult to add up electron, hence energy is to be added. So this has the value in positive, and it is the O only which has the value in negative. So here the answer will be O, right? Now this and this, I repeat, here N was positive, it's the only O which is negative. Now lithium and sodium, they belong to same group. Similar electronic configuration for the outermost shell. Here the size decreases, so the value also goes lowered. What all value was there, it is in some negative but goes on decreasing because same configuration, size increasing, value has to go down. So if this is a big negative, this will be a smaller negative. That's how we have seen questions based on electron affinity. Just repeat, In case of F, the value goes down lower as compared to expected value due to interelectronic repulsions. So this is all, and Cl has the highest value. So this is all for your electron gain enthalpy and some similar questions based on that. So we stop here for this video. In our next video, I will take up the next property, and that will be electronegativity. So I stop here. Hope things are clear to you. Fine. Thank you for this video.